Alright, let's look at the section 6.2, problem number 9. Alright, so we have a region bounded by y squared is equal to x, and x equals 2y, so that's a straight line, and about the y-axis. Alright, so let's do that. Alright, x equals 2y, it's just going to be a straight line, so I'm going to just draw a straight line there. So it'll probably look somewhat like that. Right, and y squared is equal to x, so it's a sideways parabola. So it's going to look, let's see, somewhat. Oh, let's see. I have to get rid of that. Right, it's going to look somewhat like that. Right, so this is y equals actually 2y equals x. And this is a parabola, so x equals y squared. So we are talking about this region right here. So this is the region. Alright, then what we're going to do is we're going to rotate it about the y-axis. So as you can see that it's going to look somewhat like this. Oh, shoot. Alright, maybe I'll use this. So it's going to look somewhat like this. Alright, then here on this side you're going to have that, and then on here you will have something like that. Alright, so you have it looks like a sieve or something like that. Alright, so let's find the volume of this. Alright, so there's a hole inside, so this is going to be a washer method. So we say by washer method. Alright, so let's draw a washer so that we know what to do. So if you slice it perpendicular to the y-axis, so the hole is going to be something like that, and the outer circle is going to be probably something like that. Actually, you can, I guess you can see that. Yeah, I'll just do this. Alright, so here, so volume is going to be, right, pi's over there, integral. Alright, so it's going to start from this point 0. So we know that the lower limit is 0. Then upper limit is actually up here, which is going to be the intersection between these two curves. Alright, so we're going to have to find that. So I'm going to set 2y and the y squared together. Alright, so I'm going to put, say I'm going to subtract 2y. So 0 is equal to y squared minus 2y. And factor out y, so y minus 2. Alright, which tells us that the intersection is going to be, the y value is 0 and 2. Alright, so obviously this guy is 2, 0 down here. Alright, so upper limit is going to be 2, right? And this is down with respect to y, so you have a dy, right? Then outer curve is defined by the straight guy, so you have a 2y squared minus inner curve is defined by y squared, so it's going to be let's see, y squared squared. Alright, so if we clean this out, so you have a pi integral from 0 to 2, so that's going to be 4y squared minus y to the 4th dy. Alright, so find the antiderivative. So it's a 4 is there, and a y, add 1 to the power, divide by that power, minus, add 1 to the power, 5, divide by that power. And then you're going from 0 to 2. Right? So this is going to be pi. Right? If you plug in 2, so 2 cubed is 8. And 4 times 8 is 32 over 3 minus, right? And plug in 2 here. What's this? So you have a 2 to the 5th is, let's see, 4, 12, 16, and 32. So 32 over 5, right? If you plug in 0, it's all 0. So we have that. And this is going to be pi, right? And the common denominator would be 15. Right, so multiply by 5, so it's going to be 0, 10, and 3 times 5 is 15, so it's 160 minus, and we're going to have to multiply that by 3, so it's going to be 96. So this is going to be pi. Right, so 160 minus 96 would be 64. So 64 over 15. Right, so therefore, I guess I should put the pi at the end. So here it's gonna be pi. Right, so this is the volume of the solid given there. Right, that's it. I hope that this was clear.